Now we'll move to the part 5 on the problem number 12. Write the first 6 terms of each of the following sequences, with the first one is given to be, the first term is minus 1, an is an minus 1 by n, where n is greater than or equal to 2. Okay, this problem is similar to the number 11, the second from the problem number 11, which we have been discussed on the part 4 of my channel. So you please go to that and watch it, how it has been done, how it has been solved, and you try to do this as a homework for you. Is similar, the problem is similar to that number 11, and you try to do it by yourself. Now we'll move to the next part, the next number, which is number 2. Here in number 2 is given that the first term is 4 and the n plus 1 term is given by 2n a n. Okay, now we have to find the first 6 term, okay, including this, the first term. That means you have to find up to 5 term, and including the first term which is 4, it will be the first 6 term. Therefore we are putting n equal 1 2 3 4 5 with the 6, with the first term it will be the first 6 term. Okay, now starting with putting n equal 1. N equal 1, here instead of n we are putting 1. This means a 1 plus 1 equal to n, which is 1, an, that is a1. Okay, now a1 plus 1, which is a2, the second term. Now 2 multiply 1 2, a1 is 4 given, 2 multiply 4 is 8. That means a2 it is 8. Now putting n equal to 2 plus 1 2 2 2n, 2 multiply n is 2, then a2, 2 multiply 2 is 4, a2 plus 1 is 3, that is a3 equal 4 multiply a2, a2 is 8 and 4 multiply 8 is 32. Now putting n equal 3, 3 plus 1 2 n, 3 multiply with a3. Now a3 plus 1 is a4, 2 multiply 3 is 6, a3, the value of a3 is 32, 6 multiply 32 is 192. The next, putting n equal 4, 4 plus 1 2 n, which is 4, a n 4, instead of n we are putting 4. Now 4 plus 1 is 5, that is a5, 2 multiply 4 is 8, an a4 is how much, is 192. Putting value of an by a4 by 192, we are getting 1536 as the product of these two. Okay, and next, putting n is equal 5, a 5 plus 1 equal to 5 a 5, 5 plus 1 is 6, 2 multiply 10, and the value of a5 is 1536, multiplying with 10, 15360. Okay, now we have got all the value of a1, a2, a3, a4, a5 and a6. For the first 6 term of 6 1, they are 4, 8, 32, 192, 1536 and 15360. Okay, now you try to do by yourself with the number 3 and 4, because if I solve all the problem here, we have nothing to do by itself. You try to do by yourself with the number 3 and 4, it will be somewhat similar to what we have shown you here. You just once you are clear with the method how to proceed, you can proceed ahead to solve with this number 3 and 4 also. Okay, now the next we'll move to the number 13. The sequence is defined by this rule: an is called n minus 1, n minus 2, n minus 3. Show that the first three terms of this sequence are 0, but the rest are positive. Now the first three terms, they are 0. You have to show that they are 0, and the rest they are positive. Okay, now solution for this: the sequence is given by this rule: an is called an minus 1, n minus 2, and n minus 3. That means the product an is the product of n minus 1 with n minus 2 with n minus 3. Now putting the value of n by 1, 2, 3, the first term, and then 4, we are checking whether putting n equal 4 is positive, negative, or is 0. Okay, now we have a1 is called 1 minus 1, 1 minus 2, 1 minus 3. 1 minus 1 is how much? Is 0. 0 multiply with anything which is there, it will become 0 only, isn't it? 0 with any value will give you 0 only. a2 also, here 2 minus 1, 2 minus 2, 2 minus 3. 2 minus 2, here we are getting 0, and 0 multiply to any value, you will get 0 only, isn't it? Then the same thing here with a3 also. 3 minus 1, you will get 2, 3 minus 2, you will get 1, 3 minus 3 is 0. If you multiply with 0, this will become 0 only. This means the first three terms, the first term, second term, third term, they are all 0. Whereas the fourth term, 4 minus 1, 4 minus 2, 4 minus 3. 4 minus 1 is how much? 3. 4 minus 2 is 2. 4 minus 3 is 1. If you find the product, you will get 6. Isn't it? Now, in the above sequence, what do we see? That if n is greater than equal to 3, the value of the terms is always positive. Because here, n minus 1, n minus 2, n minus 3, the largest one is n minus 3. Now, if 3 is there, if 3 minus 3 is 0, that means we cannot, the whole thing will become 0. Now, if the terms, they are the counting number, they cannot be negative counting, there always is positive counting. That means after 3, the next will be 4. Next will be 4. 4 minus 3, you will get 1. After 4, we will get 5. 5 minus 3, we will get 2. Always you will get a positive number. That means the rest of the term will always be positive, because this 4 minus 1 is, if we put 5 minus 1, which is bigger, positive value is bigger, you will get positive from here also, you will get positive from here also, you will get positive. Product of 3 positive, you will get always positive, isn't it? Therefore, we can arrive at the conclusion that the value of the term is always positive if n is greater than equal to 3. Is greater than 3, because if it is equal to 3, you will get 0. 0 is neither positive nor negative, but it will be always positive if it is greater than 3. That means from 4, 5, 6, you will always get a positive value of the term. The first term, hence we conclude at this that the first term of sequence 0 and the rest they are positive. Now the next, number 14, the Fibonacci sequence is defined by this rule. The first term is 1, which is also the second term, and the value of an is equal an minus 1 plus an minus 2, where n is greater than 2. That means you cannot put n is equal to 1 or n is equal to 2 for this value of an. because if we put n equal to, see, if we put here n equal to a 2 minus 2, this means it will be a0. a0 is the 0th term. Counting, it should start from first term, second term, third term. There is no 0th term. That's why we cannot put n equal 2. It should be always greater than 2. Okay, now we have to, giving this rule, we have to find out an plus 1 by an. For n is equal to 1, 2, 3, 4, 5. Up to 5, up to the fifth term, we have to find the value of an plus 1 by an. Okay, now solution for this is given a1 is equal 1, which is equal to just a2, and an is equal an minus 1 plus an minus 2. Now since given n is greater than 2, we are putting greater than 2, number greater than 2, that is 3, 4, 5, 6. Okay, now putting this, we have putting first with the value of n equal 3. Here a3 equal a3 minus 1 plus a3 minus 2. 3 minus 1 is 2, 3 minus 2 is 1. a2 is given 1, a1 also is 1. This 1 plus 1 is 2. Now the next, putting n equal 4, a4 will say a4 minus 1, a4 minus 2. 4 minus 1 is 3, 4 minus 2 is 2. a3 plus a2, the third term plus second term. Third term is 2, second term is 1, would give us 3. Now the putting n equal 5, 5 minus 1, 5 minus 2. 5 minus 1 is 4, 5 minus 2 is 3. Now the fourth term plus the third term. Fourth term is 3, the third term it is 2, here is 2, third term. 3 plus 2 is 5, and the last a6 is a6 minus 1, 6 minus 2. 6 minus 1 is 5, and 6 minus 2 is 4. Now the term 5 plus the term for fourth term, term 5 is 5, fourth term is 3, 5 plus 3 give us 8. Okay, now we have find the first term, second term, third term, fourth term, fifth term, and the sixth term. Now we will utilize the value of this term in finding the value of an plus 1 by an. For n is called 1, 2, 3, 4, and 5. Okay, now let us try with the first value of n is equal to 1. an plus 1 by an will be a1 plus 1 by a1. a1 plus 1 is a2 by a1. a2 is 1, a1 also is 1, which is already given, will give us 1. For second value n equal to, we are putting n equal to a2 plus 1 by a2. 2 plus 1 is 3 by a2. Value of a3, how much is a3? a3 we have just found out to be 2, isn't it? It's 2. Therefore putting the value of a3 to be 2, a2 is 1, 2 divided by 1 is 2. Now for n equal 3, a3 plus 1 by a3, 3 plus 1 is a4 by a3, that means the fourth term divided by the third term. The fourth term is how much? We have just find out to be 3, and the third term is how much? It is here, third term is 2, isn't it? 3 by, therefore the value of a4 by a3 is 3 by 2. Next, for n equal to 4, putting n equal 4, we get 4 plus 1 by a4. 4 plus 1 is 5 by a4. This means fifth term divided by fourth term. Fifth term is how much? You just go through from what we have found out. The fifth term is 5, the fourth term is 3. Fifth term here we have here fifth term is 5 and the fourth term is 3, isn't it? Therefore 5 by 3 is the value of a5 by a4. And for the last one, n is equal to 5, Same thing, we have just to put the value. You'll get a6 by a5. A6 is 8 and a5 is 5. Okay, now we have find out the value of the term an plus 1 by an for all the value of n from 1 up to 5. Now we move to the next number 15, which is very simple one. Find the 21st and 42nd term of the sequence defined by Tn is equal to 0 if n is odd and is equal to 1 if n is even. Okay, this is the given rule. Here the 21st term is odd or even. 21 is odd or even? Definitely is odd number. 42 is the even number. Okay, now T21 will be how much? T21 will be 0 or 1? It will be 0 because it is odd. And T42 it will be 0 or 1? It will be 1 because 42 is even. So simple, but the things that you have to be clear with the question. Okay, now we have come to the end of this part and we shall conclude again on the next part.